Alright, this is the last video about chapter 1 from our book, and it has to do with the absolute value equations and inequalities. Absolute values are one of the things in math that I think students really are not unsure about how to approach a lot of the time. So in this video, one of the main objectives is to really just give you a strategy to attack all of these kinds of problems confidently each time, okay? First of all, what is an absolute value? Right? This is a lesson you would have learned maybe in algebra or in middle school at some point. But if I have this on a number line, if I have 0 and I want to know how far away something is from 0, that is called an absolute value. It is just the distance away from 0 in either direction. So if I had like -7 over here, the distance away from 0, that -7's distance away from 0 is just 7. It's not -7, it's just 7. Okay, it's like a magnitude if you're familiar with the concept of magnitude. It's just a distance away from 0. So if I had, for example, if I had 0 and I had like x, and I said, or if I had, well, how can we say this? If I said that x was equal to the absolute value of 5, for example, then what I'm saying is, okay, I could be over here or I could be over here. So I could be exactly what this says, or I could potentially be the exact opposite of what this says. And another way to say this would be like, all right, I know that if this is negative x and this is positive x, that's how they would be equidistant from 0. And I know that these distances are 5 and 5. Well, what that's saying, and this is the important part, the absolute value of x is equal to 5. Meaning no matter if it was positive x or negative x, the distance away from 0 is 5. So the way you would tackle this is like this. This could be exactly what it says it is, meaning x is equal to 5, or it could be the exact opposite of what it says it is inside here. So -1 times x is equal to 5. How do we get the exact opposite of something in math? It's by multiplying it by -1. Okay, so we could have this too, which of course then you divide both sides by -1, or multiply both sides by -1, and you get x is equal to -5. So that's how we get, when we're typically dealing with this, we just immediately write the answer as x is equal to plus or minus 5, positive or -5. Okay, but that's it. Now, this is a very simplified idea, but it applies to even very complicated problems. Let me give you an example of a slightly more difficult one. Okay, the absolute value of 2x minus 1 is equal to 7. So we're going to do it the same exact way we talked about. Okay, we're going to break it into two things. It could be exactly what it says it is. Just remove the absolute values. It could be this, or what's inside here could be the exact opposite of what it says it is and still be 7 away from 0, right? So it could be -1 times 2x minus 1 is equal to 7, which is, of course, if we distribute the -2 in, -2x plus 1 is equal to 7. Now, if you were to not do that last step and divide both sides of this by -1, you get that 2x minus 1 is equal to -7. So you see, I can write what's inside the absolute value out twice and then set it equal to what it says it's equal to, or the exact opposite of what it says it's equal to. There is that other step though, okay? That's not really what's happening here. It's the thing inside the absolute value could be the opposite thing. And the reason that that distinction is important is when we get into inequalities. Because as we know, when we divide both sides by -1, which we did right here, we have to flip the sign. And so when you're dealing with an absolute value inequality, there's a sign flip that comes into play. And we'll encounter that, and we'll look at how to deal with that when it happens. But just to finish this problem off, okay, what would happen here is we just, you add 1 to both sides for this one. So 2x is equal to 8, so x would be 4 if you divide both sides by 2. And over here, add 1 to both sides. 2x would equal -6, so x would be -3. So x is two things. You could say x is equal to -3 comma 4, or you can write it as like a solution set, -3 and 4. Okay, so an absolute value will probably have two answers, and that's going to be prophetic because when we get into inequalities here in a second, they're going to have two answers. So again, they're going to be compound inequalities. So let's look at a compound inequality in the form of an absolute value inequality. And we're keeping all the same numbers here. So let's do this again the way that we just talked about. I'm going to write it slightly different on the screen. Okay, I'm going to have one inequality here and the other inequality here. So what we have is exactly what it says it is. 2x minus 1 is greater than 7. Or we take the exact opposite of what's inside the absolute value, multiplied by -1, and that's greater than 7. If we divide both sides here by -1, we get this. 2x minus 1 is less than -7. We had to flip the sign because of dividing by the negative there. Okay, at that point we can work both of these out. Okay, this is going to end up being that x is greater than 4 after you solve for x. I think that's manageable at this point. And this one is going to be x is less than -3. Okay, once you solve for x in that one. Okay, now this is kind of where these can get. I recommend 100% doing it the way that we've just shown here. Okay, because when you get more complicated absolute value things, which we'll get in a minute. Doing it this next way is going to make things kind of very confusing really quick. Okay. The other way though to deal with this is to note how we have this statement. Oops, sorry, that's a strange color. Is to note how we have this statement 2x minus 1 and this statement 2x minus 1 in both of these two different inequalities that we wrote. And note this is the same problem. So if I go and if I say 2x minus 1, oops, sorry, 2x minus 1 is less than -7, like I did right here, but it's also, 2x minus 1 is also greater than 7, like it is right here. Well, there you go. That is a compound inequality. You wouldn't normally write it like this because you write the lower number on the left. So let me revise that. We'd say 2x minus 1, like looking at the left one first, that's greater than 7, but it's also less than -7, so less than -7. So we write it then as this compound inequality. Then you can proceed to solve it that way, where what you do to the middle, you have to do to both the sides. So we have -6 is less than 2x minus 1 is not minus 1 because we got rid of that, is greater, or sorry, is, wow, but I totally messed something up here. Sorry, this isn't like that. I don't know. I said less than and I wrote greater than. My bad. Just like that. Okay, so -6 is less than 2x is less than 8. Okay, and then if you divide everything by 2, you get -3 is greater than, is greater than x. I'm misspeaking here, sorry, is greater than 4, which of course is what we have here. We have x is less than -3 and x is greater than 4. It's just like that. Okay, and then you can graph this. Okay, you can do your, this would be it's greater than, or this is going to be a disjunction. We're going to have -3 and 4. We're going to have open circles, so it's going to be, well, let's do it in a different color. It's going to be like that, like that. So the answer to this is -infinity to -3 union 4 to infinity, not including any of that. And that's how you do it. Okay. Now let's make it a little bit more difficult. One more just like this sort of first, and then let's make it more difficult. So the absolute value of x minus 1 plus 2 is less than 4. Now, the whole idea where you say the absolute value is just what it says it is, or the exact opposite, only applies if your absolute value thing is by itself. So you got to get rid of that first. If you had a coefficient out in front, you can choose to either get rid of it or not. I recommend yes. Okay, but that's a multiplication, so it's not going to change the relationship. This plus 2 does, though. So we got to, the very first step would be to get the absolute value by itself. So we have x minus 1, the absolute value of x minus 1 is less than 2, right? Because 4 minus 2, subtract 2 from both sides. Okay, at this point, we're going to do the two different inequalities. Okay, we're going to say we have either x minus 1 is less than 2, or x or -1, the exact opposite of what's in here. And you can choose to kind of skip this step, but it's good to keep it. X minus 1 is less than 2. If you divide both sides here by -1, we get that x minus 1 is greater than -2. So these are our two inequalities now. We solve them. Okay, plus 1 plus 1. X is less than 4. 3 2 plus 1 is 3, and x is greater than, if you add 1 to both sides, x is greater than -1. So this is, if we read this out, it would be a, what would this be, an inequality? It would be we would have this, it's a -2 is less than x minus 1 is less than 2. This is an and statement. It's going to be a conjunction. Okay, but the way we would solve this, though, is to put it on a number line. Okay, graph these independently, like above the number line. So we'd have 3x is less than 3. So we're going to go over here. That's 3 right there. And we have -1. And then we also had x is greater than -1. So it's like that. Where do they overlap? They overlap right here. So it's an and. That's an open circle. It got all messed up. It's an open circle. Okay, so how do we put that in interval notation? -1, 3. Something that confuses people about interval notation is that it looks just like a coordinate point, and it does, and that's just an unfortunate thing that they look very similar, have the same kind of symbols. Okay, now we're going to go into the last problem here. This problem is genuinely, it's pretty difficult. Okay, but we're going to remember how to deal with absolute values and what to do when we have just a difficult looking inequality. Okay, so we'll do that step by step. First of all, what would cause this an issue with this problem, right? Like, what do you see right away? What you should see is that if x was 4, we'd have a divide by 0, which is undefined, which would make this make no sense whatsoever. So that's a problem. We're going to identify that right away as a critical point. Okay, so there's a critical point at 4, and this is an asymptote. Great. At this point, now we're going to go and do our boundary. We're incorporating both the boundary method here and our knowledge of how absolute values work. So start with the absolute value part. We've got two different things. It could be that x minus 1 divided by x minus 4 is less than 2, or it could also be that the exact opposite of this, -1 times this, is less than 2, which again, now this is that step I'm saying you could skip. If you divided both sides by -1, right, you would just have this. You'd have x minus 1 divided by x minus 4, flip the sign, -2. So you could set the opposite relationship to the opposite thing and be okay too, and just go straight to that. But if you're confused by that, don't skip the step. Just put the -1 out in front, divide both sides by the negative, know that means you flip the sign, and then you're good to go. Now we're going to solve both of these inequalities separately and identify the different possible zeros that come up. So what do? Well, we can we subtract. We have actually there's two ways to do this. Okay, you could multiply both. I'm looking right here. Okay, looking at this one, we could multiply both sides of this inequality by the quantity x minus 4. And when we work our way down, we're going to get x related to something, and that's going to be a 0. And we can do the same for the other one. But the way that we talked about doing this will illustrate both that asymptote is still a thing and the 0. So we're just going to do that. Okay, but you can totally shortcut this. So we're going to say x minus, oops, sorry, this should be in red. X minus 1 divided by x minus 4 minus 2 is less than 0. This is the part of the boundary method where we have to set the relation equal to 0, right? Now we're going to multiply this 2 by our common denominator, x minus 4. So we'll have x minus 1 minus 2 times x minus 4 all over x minus 4. So we'll have at the end of, that's a 0. We'll have at the end of this x minus 1 minus 2x plus 8 divided by x minus 4. So we have then negative x plus 7 is divided by x minus 4 is less than 0. So this here is our the 0 on the numerator there would be 7. So we have another critical point. If x was 7, we'd have a problem here. So 7 is a 0. Okay, these are all going to be open circles anyway because it's not an or equal to, but we got identified another 0. But there's another 0 that we have to identify by doing that for the other inequality that we came up with. So we're going to do that one now. Same idea, x minus 1 divided by x minus 4 plus 2 now. I'll just put in this step because we're going to need it in a second. 2 times x minus 4 divided by x minus 4. Okay, x minus 1 plus 2x plus or minus 8. Minus 8 divided by x minus 4. And on the top then we'll have 3x 3x minus 9 divided by x minus 4 is greater than 0, right? So what would x need to be in order for this to be a 0? It would need to be 3. Okay, so 3 is my last critical point. Okay, cool. We got it. Now we're just going to go ahead and do the boundary method. And there's kind of a tip here for this particular kind of problem. Okay, because it's not super complicated, these numbers aren't so bad. Let's put them on the number line. 3, 4, and 7. What we're going to do is we're actually going to plug the number really back into our original problem that was given to us and see if it's true or false. So this one we actually have to plug the number in instead of just seeing if it's positive or negative, because in our original problem we're not evaluated to 0. Okay, we're not set related to 0. So it's related to 2, we got to see if it's true or false. So let's plug in this region here, let's plug in 0. If we plug in 0, we'll have, well, let's do this a little bit differently. If we plug in 0, we'll have 0 minus 1 is less than 0 minus 4. Is that less than 2? So negative 1 divided by negative 4 is positive 1/4. The absolute value of positive 1/4 is 1/4. Is that less than 2? It is, right? So this is true over here. Okay, now let's pick a point between 3 and 4. So this one kind of sucks because we have to do like 3.5 or something. So if we plug in 3.5, 3.5 minus 1 divided by 3.5 minus 4, that's going to be 2.5 divided by negative 0.5, which is negative 5, right? Now, absolute value of negative 5 is 5. Is 5 less than 2? No, it's not. So this is false. Okay, and then we'll pick a number here between 4 and 7. So maybe 5. If we plug in, is this less than 2? No, it's false. Okay, this one, if we plug in 5 minus 1 divided by 5 minus 4, 5 minus 1 is 4. 5 minus 4 is 1. So 4 divided by 1 is 4. The absolute value of positive 4 is 4. Is 4 less than 2? No, so this is false. Okay, and then lastly, let's pick a number greater than 7, so like 10. Then we'll have 10 minus 1 divided by 10 minus 4. Is that less than 2? 10 minus 1 is 9. 10 minus 4 is 6. 9 divided by 6 is 3 halves. Is 3 halves less than 2? Yes, so this is true. Now, I didn't mention this before, but the power of the boundary method is that since we've established these critical points, we know that every point between these points has the same behavior, which is why we can shade. Okay, it means that everything from negative infinity to 3 has the same characteristics. It's all going to be true for that part, right? Same thing between 4 and 7. Sorry, not 4. Not 4 and 7. So let's pretend I didn't scroll that in because I can't undo it. 7 and greater, right, was true too. And we have open circles everywhere. I notice I have this open circle here, but it didn't end up mattering, right? That was our asymptote. It didn't end up mattering in the end. So our answer is going to be, in interval notation, from negative infinity to 3, union 7 to infinity. And that's it. Now let's look at the graph of this, because this is a weird thing. How do we know what this graph looks like? So this is our graph of this. We had the asymptote there at 4, remember, and then we had these zeros at 3 and 7. So this was saying, when is this greater than 2? When we move the 2 over, what it's looking for, what it ended up wanting was, when is it less than 0? So we had these things here. Okay, it was everywhere from negative infinity to 3, and when it was everywhere from 7 to infinity, not including these because it's not or equal to. So this is a very difficult problem. This is about as hard as an inequality can really get. But as long as we follow the steps, we think about the boundary method and how to deal with absolute values, we'll be good, right? And no matter how difficult they get, I promise it'll work this way.